Now in the previous video, we studied how we use the oscillator methodology, which makes things pretty fast to check on divisibility of certain numbers. Now in this video, we are going to talk about, or we're going to learn how we compute the oscillators. Right? So our computation of oscillators, I'm going to divide into three parts. The first part, I'm going to talk about calculating oscillators for numbers with last digit 9. So let's take an example. Let's say 19, right? So we have to calculate the oscillator for 19. So for all the numbers whose last digit is 9, what I'll do is I'll remove 9 and what I'm left with is 1, right? So the number that I'm left with is 1. I'll just add a 1 to this number 1, right? And I get a 2. This is the positive oscillator for the number 19, right? So let's take other examples. Let's say we have to find the oscillator for 29. So what I do, I remove the 9, I'm left with a 2, this 2, right? I add 1 to it and the oscillator for 29 is plus 3. Then likewise for 59 it will be 5 plus 1 plus 6. For 79 it will be 7 plus 1, which is plus 8, and so on, right? So this is how I'll find the oscillator for all numbers which have 9 in the units place, right? And I could go on and on. So for example, for 109 it would be 10 plus 1, 11, right? Now the second case is when the last digit is 1. So when the last digit is 1, this time what I do, I'll take the example of 11. This time what I do is I just remove the last digit just like I did for 19. I remove the last digit, which is 9. Now I'm left with 1, okay? So my oscillator is this digit, the number formed by what is left and a negative sign. These are negative oscillators, right? So the oscillator for 11 is minus 1, plain and simple, right? Likewise, let's find out the oscillators for 31. So for 31 it's going to be, I'm left, when I remove 1, I'm left with 3. So 3 with a negative sign is the oscillator for 31, right? So for the rest of them, 41 is minus 4, 61 is minus 6, 71 is minus 7, and so on, okay? So this is how I find the negative oscillators. So for digits, for numbers ending in 9, remove the 9, add 1 to the rest, and the positive oscillator is what I get. For numbers ending in 1, remove the 1 in the end, what is left with a negative sign is the oscillator for that number, right? But what happens if our numbers are, let's say, ending in 3 or ending in 7, right? So let's take an example. So for 13, so ending in 3 or 7. Now I'm not taking up even numbers because what we can do is we can separate out the two, and whatever is left we can check for its divisibility separately. I'm talking about, I'm talking in the context of prime numbers, right? For whom division or multiplication is not so straightforward. So for all the prime numbers, actually all numbers who end in 3, right? Let's take the example 13. Now what I'll do is I'll simply multiply 13 by a certain natural number so that the result ends in either 1 or 9, right? So 13 times 3 is 39. So what I do is multiply 13 by 3. So I'm finding the oscillator for 13. So 13 times 3 gives me 39. So the oscillator for 39 by using this method is I remove the 9, I'm left with 3, I add 1 to it, and I get my positive oscillator 4. So 4 is the oscillator for 13. Likewise, let's try 23. So 23, straight away I don't know what to do, but I can multiply 23 by 3 and we get 23 times 3 is 69. I remove the 9, I'm left with 6, I add 1 to it, and plus 7 is the oscillator for 23. right? Now what happens if let's say a number is ending in 7? Let's take the example of 17. Now for 17, what we will do is 17 times 3 is 51. So I just multiply 17 with 3, I get 51. Now any number ending in 1, the oscillator is easy to find. So what I do, I pick up 5 but with a negative sign, that becomes my oscillator for 17, right? Likewise, oscillator for 37. Oscillator for 37 is, I'll multiply 37 and 3 and I get 101. Right? So I remove the 1, I am left with a 10, and 10 with a negative sign is the oscillator of 37. Right? So hopefully with this video it is clear how we can very quickly find the oscillator, and when we combine our learnings in this video and the learnings in the previous video on how to use oscillators, we can very quickly check the divisibility for all the different and difficult prime numbers and so on and so forth.